Welcome to a lesson with Dr. Pal. Let's talk about how, if we have a short exact sequence of our modules, and A and C here in this diagram are Noetherian, that B must also be Noetherian. So what we're going to do is we're going to think, okay, we have an ascending chain of submodules of B, and suppose in there eventually what's going to happen is their pre-images over here, which are ideals in A, are going to stabilize, all right, because A is Noetherian, and these are this is an ascending chain of submodules here, and likewise in C, all right, the images of these submodules are going to stabilize as well. We can use that stabilization over here and over here to see that we'll actually have stabilization here. So by way of contradiction, let's assume that we don't have stabilization, that we have um, uh, that mj right here is non-trivially included in m sub j plus 1. Okay, now let's think about what we can do. Now, first of all, okay, so we take a pre-image here, and these pre-images are going to be the same. Now we take those, so this is the same guy right here, and we could just label it as this if we want. And if we push it forward, this is the same thing. We push it forward back into B, we're going to call that K. Now think about what K is. Um, so the map F right here, we can think of F of A as being the kernel of G because this is an exact sequence. And it's an injection here. And if we think about um, F being restricted if we restrict its codomain to F of A, then it's an actual isomorphism going on right here, which is kind of nice. It'll be a bijection, meaning that if we when we pull back from here into A via F, anything that's not in the kernel, which is the image of F, is won't have a pre-image at all. So anything that does have a pre-image that comes back to here will, when we push it back via F here, we're gonna land at the exact same element. In other words, when we push it forward, we're going to get something which ends up being all the elements of our current um, submodule that here that are in the kernel. So it's going to be the intersection of the kernel with that module here. Which so if we mod out, so modding out by this, which we're going to call K, which notice is going to be the same in both cases. Now, why is it the same? That's because, well, this guy was the same, right? The pre-image of this was the same as this. So really, this labeling is this. So these are the same. This is the exact same submodule K that we're going to be modding out by here and here. So this submodule modded out by K is the same in both cases. Okay, so and now when we do that, since K represents everything that's in here that's in the kernel, we've actually produced an isomorphism between this and the image of mj plus 1, as well as this quotient right here will be isomorphic to the image of mj. And we know these quotients are equal. Okay. And we also know between this quotient and there's an isomorphism. All right, same isomorphism here. So let's think about what's going on for a minute. So if we take something that's in m sub j plus 1, but it's not in mj, so y, all right, we can think about the coset of k, so y plus k. Okay, so that's an element of this quotient right here. Because because this is an isomorphism and these guys are equal, we have to think that this hits every single, so all of the cosets here with representatives MJ hit every single, also have the exact same set of images as the cosets over here. And this is an isomorphism. So let's remember that. So again, we're taking some y that's in MJ plus 1, but not in MJ, and we look at its coset, and we look at the coset with, we know that because these images are the same, we know that there has to be a coset coming from over here that's going to map to the same place. Okay, so we have um, so the image of x plus k is going to be the same as the image of y plus k for some x. Now remember, because of these, and we can focus up here if we want to, because x plus k and y plus k are both cosets or both elements of this quotient, and both of them are going to have the same image. Well, that forces, because it's an isomorphism, that these two elements, it's a bijection, so these two elements of the quotient, these two cosets are going to be identical. They're going to be the same. Well, what does that mean for y? I mean, y plus some element of k is going to put you in x plus k. Well, that means that immediately that y is actually in this this element of the quotient. All right, x plus k. Which, well, remember that x is uh, where was x and where's k? K is completely contained in mj, and x is contained in mj, which means that y is also in m sub j. Ooh, but that's a contradiction. That contradicts our initial assumption. So, what does that mean? That means we can't pull a y from here, so that these guys are actually equal, and we actually have stabilization here eventually with this ascending chain of submodules of B, which shows that B itself is Noetherian. And that concludes this little proof that we have of B being Noetherian. Thanks for watching.